This is part 5 of the Module 6 lecture. In this case, we're going to learn to use a normal distribution to solve some problems. All right, in this first example, and my purpose of including this example here is to show you the three-step procedure that we follow to solve this kind of problems. So in this type of problems, you will be told that there is some random variable, x in this case, that is normally distributed with a mean of 80 and a standard deviation of 10. So in these problems, you are always given the mean and you are always given the standard deviation, and they ask us to find a probability. In this particular case, we want to find the probability that the random variable is less than 95, and we are going to use table 4. Now remember, table 4 is giving us the probabilities from the standard normal distribution. That means we need z values to find the corresponding probabilities. So the first step in this type of problems is to transform the x value, 95 in this case, into a z-score. And it's 95 because they're asking us to find the probability that x is less than 95. So to find the z-score, we take the value of 95, we subtract the mean, which is given, and we divide it by the standard deviation, which is given. In this case, if you carry out that calculation, is 1.5. Now, in all these problems, I always include the sketch of the normal distribution, the x scale, the z scale, and the corresponding x sub 0 value and the z sub 0 value. And then I shade the area of the probability that I'm interested in finding. In this case, we said we want to find the values of the random variable less than 95. That means to the left of the value. Right. Once you have the z-score, then you go on to table 4 and you find the probability that z is less than 1.50. That means you're going to go on to the second sheet of table 4 because z is positive. You're going to look in the column, you're going to find 1.5 and look at the very first entry because the second decimal place is 0. And you will, if you look at the table, you will find that it's 0.933. Now, we know that the corresponding value for an x value of 95 in the z-score will be 1.5. So the probability that the random variable is less than 95 is the same as the probability that the random variable z is less than 1.5. So here's the probability that we're looking for. So once you find that probability, the third step is to interpret that value. So in this case, the probability that the random variable x assumes values less than 95 is 0.933. Now, I'm a little different from the textbook in here because I'm distinguishing between the random variable and values of the random variable. So whenever you see a capital letter, that means that is a random variable. Whenever you see a lowercase letter, that means a particular number or a particular outcome of the random variable. All right, now that we've seen this three-step procedure, let's solve some problems. So in example 2, a survey indicates that people use their computers an average of 2.4 years before upgrading to a new machine. The standard deviation is given as 0.5 years. And they're asking us to assume that the time to upgrade is normally distributed. So we would like to use table 4 to find the probability that a computer owner selected at random will use a computer less than 2 years before upgrading. So we want to find that probability. Right? So now using the information in the problem, we're going to summarize it like this. So the random variable is time to upgrade, is normally distributed with mean of 2.4 and a standard deviation of 0.5 years. They want us to find the probability that the random variable, in this case, time to upgrade, is less than 2 years. So the value is 2. So now we need to change that value into a z-score. So we take the value of x, 2, we subtract the mean, which is 2.4, and divide that difference by the standard deviation, which is 0.5. If you carry out that calculation, that's minus 0.80. So here, this sketch of the normal distribution is showing you that we're looking for the probability that this owner will upgrade his computer in less than 2 years. So we're looking for a probability to the left of the x value of 2 or the equivalent value of z of minus 0.8. So we're looking for a probability on the left side. So then remember that table 4 gives us those probabilities directly, probabilities to the left of the value, the z value that is. So if you go into table 4, look for minus 0.8 in the first sheet of table 4 because z is negative, you will find that that's 2.119. Because the z value of 2 is 0.8, then you know that the probability that the time to upgrade is less than 2 years is the same as the probability that z is less than 0.8, and that's 0.2119. Right? So the third step, once you have found the probability, is to interpret that probability. So the probability that a computer owner selected at random will use his or her computer less than 2 years is 0.2119 or 21.2%. Now I'm going through all the trouble to interpret these probabilities because this is what I'm going to ask you to do in the quizzes and exams. Interpret your results, always. All right, here's another example, example 3. In this case, a survey shows that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. So the length of time spent in the store is normally distributed. So we're going to use table 4 to find the probability that a shopper that enters the store will spend between 24 and 54 minutes. In the second part, we're going to find the probability that the shopper will be in the store more than 39 minutes. And then in the third question, say, well, if we have 200 shoppers coming in, how many do you expect to be in the store more than 39 minutes? That means we're going to use the probability in B to find that number of shoppers. All right, let's solve this problem. So now the information that is given in the problem, I recommend that always summarize that information so that you know what information we're dealing with. So in here, the random variable is the length of time spent in the store. It's normally distributed with a mean of 45 minutes and a standard deviation of 12 minutes. Now, the first question is find the probability that a shopper entering the store is going to spend between 24 and 54 minutes in the store. They're asking us this probability right here. So the first step is find the z-scores for the two x values, 24 and 54. And here are the two calculations, the z1, which corresponds to x1. So again, we take the value, subtract the mean, divide by the standard deviation, and we find minus 1.75. Similar calculation for the upper value, x2 of 54, we find that that corresponds to a z value of 0.75. Here's the sketch of the normal distribution with the two axes, the x values and the z values, and the probability we're looking for, the probability between the two values. All right, so once we get an idea of what probability we're looking for, then we go into table 4 and we find the probability that z, the random variable z, is less than 1.75, and you will find that that's 0.401. And then the probability that the random variable z is less than 0.75, and you will see that that's 0.7734. And if you remember from the previous part where we have the probability that a random variable is between two values, we subtract the smaller probability from the larger probability. And that's what I'm doing in this part. So to find this probability that the shopper is in the store between 24 and 54 minutes, it's equivalent to asking that the z value is between minus 0.75 and 0.75. And as I mentioned, we subtract the smaller probability from the larger probability, and you see that we find 0.7333. Once you have the probability, then you interpret. And that this probability means that the probability that a randomly selected shopper entering a supermarket will be in the store between 24 and 54 minutes is 0.7333 or 73.3%. All right, so this is the answer to part A. To part B, we want to find the probability that a shopper will be in the supermarket store more than 35 minutes. So again, here's the value of x is 39. We find the z value the same way we did before. That's minus 0.5. Here's the sketch of the normal distribution. And now you see we're finding for values larger than 39. We want to see that a shopper spent more than 39 minutes. That means we're looking in the for the probability on the right of the value. And if you remember from what we did in the previous section, so we find from table 4 the complement of the event that we want, the probability that a shopper spend more than 39 minutes. So with this z value, you go into the first sheet of the table 4 and you find the probability that the random variable z is less than 0.5 is 0.3085. So then you know that the probability that a shopper will be more than 39 minutes in the store is 1 minus the probability that z is less than 0.5. So we're using the complement here, and then you find that that is 0.6915. So once you have this value, then you interpret. So the probability that a shopper will be in the store more than 39 minutes is 0.6915 or 69.2%. So this is an example where we use the complement to find the probability we're looking for. All right, the last part of this problem is it says, well, if you have 200 shoppers entering the store, how many would you expect them to spend more than 39 minutes in the store? So we already found in part B that for one shopper to be more than 30, the probability that one shopper that enters the store will be more than 39 minutes is 0.6915. So for 200 shoppers, we multiply 200 times that probability, and you see that 138.3 of the 200 shoppers will be in the store for more than 39 minutes. So again, once you find the result, then you interpret the result. So we will say that about 138 of the 200 shoppers will remain in the store more than 39 minutes. All right, we have another example. In this case, we have a situation where a racing car is one of the many toys manufactured by Mack Corporation, and they know that the assembly times of these toys follow a normal distribution with a mean of 55 minutes and a standard deviation of 4 minutes. And the company closes at 5 p.m. every day. So if one worker starts to assemble a racing car at 4 p.m., what is the probability that she will finish this job before the company closes for the day? So in this case, the random variable is time to assemble a car. We know it's normally distributed with a mean of 55 minutes and a standard deviation of 4 minutes. So if the worker starts at 4 and the company closes at 5, so we're looking at she has 1 hour to assemble a car. So this is the x of 0.60. So we subtract the mean divided by the standard deviation, and then the z value is 1.5. So again, we find the probability that z is less than 1.5, and that's 0.8944, and we find that on table 4. So the probability that this person will be able to finish assembling the car in that 1 hour is 0.8944. So the interpretation of this probability then is that the probability that the worker will finish assembling this racing car before the company closes for the day is 0.8944. All right, so here are a few examples of how to use a normal distribution. And please look through them carefully. And then in the Wiley Plus assignment, I gave you a few more, so I'm sure you're going to get plenty of practice using Table 4 to solve interesting problems. All right, I will stop here, and then we'll continue with the next section in the next recording.